Alright, so we're going to look at finding the derivative dy dx in terms of t. So normally when we do the derivative, it's going to be in terms of x, but in this case, we're going to do it in terms of t because we're dealing with these parametric equations. Two basic steps: find dx dt and dy dt. So find the derivative of each equation in terms of time. Then find dy dx by dividing dy dt by dx dt. So let's look at this and see how that kind of makes some sense. If we have dy dt divided by dx dt, that's the same as taking dy over dt times the reciprocal of this, which would be dt over dx. If you think of it that way, the dt's cancel out, and we're left with dy dx. Right, so in order to find dy dx with these parametric equations, we have to take dy dt divided by dx dt. So let's go ahead and take a look at this first one, number 5. We want to know dx dt. So to figure that out, what we're doing is we're just taking the derivative of both sides with respect to time. So on the right side, that's fine because that's the variable. Over here, when we do the derivative of x with respect to time, well, derivative of x would be 1, but then we have to multiply by the derivative of x with respect to time, which is dx dt. Right. On the right side, since these variables match up, this is just going to be 2t. Right. Derivative of the constant is 0. This one, we take the derivative with respect to t on both sides. On the left side, derivative of y is 1, but then since we're doing it in terms of t and not y, we get dy dt. Over here, it helps to kind of think this instead of t over 2, think of it as 1/2 t. What's the derivative of 1/2 t? Just 1/2. Right. So, to find dy dx now, all we're doing is taking dy dt divided by dx dt. So we get 1/2 divided by 2t. But we don't want to leave the fraction in there, so we can think of this as 1/2 times the reciprocal of 2t, which is 1 over 2t, which gives us 1 over 4t for dy dx.